Okay, good morning to all of you. In this class, we are going to discuss correlation. That means if we are going to consider two random variables, suppose x and y, two random variables, how they are linked with each other, how they are related with each other linearly. I am telling you about the linearly. Linearly, how they are related with each other, how much they are related, up to which degree they are related or linked, you can say linked, linearly linking or coupling, you can say coupling, linearly linking or coupling, COUP, coupling with each other, these two random variable is nothing but called as the correlation. And this topic also we are going to discuss uh, these things, how the two random variables are going to be linked with, linearly linked with each other or coupled with each other, and in which way we are going to estimate or up to which degree they are linked, that also we are going to be discuss. And up to which degree, up to which degree they are linked with each other, that can be determined by considering correlation, correlation correlation coefficient, that we are going to discuss in detail, that is small r. Okay, small r. So let's start. Here I given a simple variation, that is your along x axis I have been taken height, along y axis I have been taken weight. You just imagine the group of people. If height increases, the probable of increasing of weight is there. That means you just imagine, close your eye and you just imagine, if height will be increased, uh, then weight most probably it will be increased. Maybe it will be decrease or maybe it will be constant, but mostly chances that the height increases means the weight also increases. So here I represented some data that for this height, this is suppose the weight, and for this height, suppose this is your 5, suppose 5, 10, uh, 15 and 20, like this. So from 0 to 5, when height increases, suppose we have to consider, instead of 5, we have to consider 50, 50, 100, 150, 200, 250 centimeters. Okay, the height measured in the centimeter and the weight measured in kg. Suppose you just imagine 50 centimeter one person or one boy or girl having the weight, suppose this one 100 centimeter. If height increases, then his or her weight uh, increasing probability is much more. That means we can expect that if height increases, his and her weight also increases. Suppose here in this data, the increment is this much for this 50. Again another 50, if I increased the height, the weight increases this much. So that means if we are going to consider each and every 50 centimeter increase of height, here we can say see that a trend of increase of weight we found. Likewise, if I will decrease the height, a trend of decreaseness of weight also we found. That means these two random variables, if I am going to consider this is your x and this is your y, two random variables, they are correlated in such a way that if one increases, another increases, and if x decreases, this is also decreases. This is one example here I represented. Likewise, another example I can show you, that here suppose we are going to consider the temperature on the earth. I am considered here 5 at morning 5 am to 1 pm. Suppose this much time I considered. You just imagine that as we are going to increase the time from 5 am morning time, morning to afternoon 1 pm, the temperature on the surface, earth surface, it will be accordingly will increase. Okay, so here as the time passes from 5 to 1 pm, temperature increases, So here the trend is this one. Okay. So another example that you just imagine your preparation for an exam. Preparation time or preparation percentage, you can say preparation time along this axis. The x is represent the preparation time, and y, this y is represents percentage in the exam. So obviously how much time you are going to be prepared, that much percentage you are going to get in your exam. So if the preparation time will be increased, the percentage in your exam, getting the percentage in your exam will be increased. So the relation between preparation and uh, mark or percentage in your exam is like this, related like this, or correlated is like this. Okay, that means if this will be increased, this also will be increased. So each and every uh, for each and every preparation time, if I am going to consider the percentage of uh, exam percentage, so it will vary more or less like this. So averagely if I'm going to draw a line, it will be passed through here, and the trend is telling that if it will increase, this will be increase, right? Okay, so another example I am going to represent that. Here you can see that we are going to consider volume and pressure. Suppose this is your cylinder. If I will be consider its increase of volume, suppose this is your initial volume. If I will press upon this piston, then the volume will be decreased, that means pressure will be increased. So if I will be expand this piston, then volume will increase and the pressure will be decreased. So if we are going to consider volume along x-axis, or the variable, random variable x represent volume and y represent your pressure, then both are related linearly. That means volume increases, pressure decreases, or volume decreases, pressure increases in this trend. So if we are going to consider in one way that volume increases, the pressure decreases, this one. So here this type of variation, this type of relation is called as your the correlation in negative way. So this is called as your positive correlation, this is called as the negative correlation, and this is also, this is increases positive correlation, this is also positive correlation. Another negative correlation I can show you that here, price and demand of a product. Okay, so if price of a product, suppose this is a product, and the price of the product if it increases, then the demand of the product, that means the peoples will be less buy this product, that means demand of the product is going to be decreases. So price increases along x-axis, suppose I taken random variable x and y is the demand. So price and demand will be give you negative correlation, right? So this is this type of relation or the correlation is called the positive. If one increases, another increases, and one decreases, another decreases, also positive. If one increases, here you can see one increases, other decreases, and one decreases, volume decreases, pressure increases, this type of correlation called a negative correlation. Okay, so here we somewhat discussed about the correlation between the different two random variables x and y. Okay, what in which way we have to maintain our note for the exam point of view. Here I am going to give you the instruction. Carefully you have to observe and pause the video or write down the note. Okay, here you can see that first you have to put the heading, that correlation, whatever it has been written, you just write down. Okay, it is easily readable, no problem. Whatever I have been discussed, it is written. So in bivariate distribution you may interested, blah blah, everything it has been discussed. If two variables deviate in same direction, that is if increases or decreases in one result, it corresponding increases decreases, whatever I we discussed. So you just write down up to this much, and draw the examples. See, height, weight, one example of the positive. Income and expenditure. If income will be increased, obviously expenditure will be increased. So this is also a positive correlation. And negative correlation, price and demand, what I discussed. Volume and pressure, what I discussed. And another two graphs I have been discussed here. It is not mentioned in the book, that time, temperature and preparation and a percentage in your examination. So what you have to do, that you have to write down first up to this much, then draw the examples. You have to draw this example, height weight example for positive correlation. This one positive correlation you have to draw, this one also you have to draw, and for the negative correlation you have to draw this one, pressure, volume and price and demand. Okay, then you have to put the heading about scatter diagram. Okay, scatter diagram. Here uh, after writing heading the scatter diagram, you just draw this graph, these graphs. Okay, this graph, that means here you can see, uh, for each and every value of x we have y value. Okay, so if I will draw the average line here, it shows that it is increasing trend in this way. That means if x increases, y also increases, right? But here if x increases, y decreases. That means here positive correlation, negative correlation. And here r is greater than 0, r is less than 0. Here r is represents the uh, coefficient of correlation. What is coefficient of correlation, I will discuss, you just wait. For this one, coefficient of correlation is positive, and this is for negative. And for this scatter plots, here it is 0, because if I will draw a average line here like this. Okay, that means for each value of x, that means here we can see that the y is constant, y is not varies with respect to x, the mean of y not varies. So here coefficient of correlation, that means r equal to 0. Here r equal to 0, it is represents that x and y, two random variables, they are not correlated with each other. This represents r is negative, it represents that x and y related with each other negatively. For this it is positively related. And here these two plots, that is r equal to +1, r equal to -1, this represents also positive correlation. That means x increases, y increases, but perfect correlation. There is no scattered point we can found for this case. That means for each x value, definite y value, and it will follow a straight line path. That means perfectly correlated, there is no variation at all. Okay, here average variation, if we are going to consider, it is increases. But if I am going to consider, suppose you see that this data and this data nearby data, suppose this data and this data you consider. Here if I am consider these 2 points, if I will increase x, here y decreases. You got my point? See, if I am consider these two data here, for this case, here if x increases, y decreases, but averagely it is increases. But here in this case, for your graph, fourth graph, you can see that perfectly they are correlated perfectly. That means constantly it is increased for this case, constantly it is decreased for this case. Okay, that means it is perfectly correlated, for positive correlated, and this is your negative correlated, perfectly negative correlated. Okay, so what I told that, you have to do one thing, that you have to put the heading scatter diagram, and you just draw these diagrams. Okay, then you just write, see, you just written scatter diagram, then you just write one thing, that nothing you have to write, only you have to write this much. From the scatter diagram we can get idea. Here I written get. Okay, we can get idea whether the variables are correlated or not. This much you have to write, and you draw the figures. whatever I told, these figures you have to draw. Okay, next we have to go for the uh, Karl Pearson coefficient of correlation. Okay, what I told, that R is called as your coefficient of correlation. With the help of R, we can evaluate the degree of correlation, how much intensively, or on how much intensively, or you can say degree of linear relationship between two variables, that will be give you the R value here. Okay, you just put the heading. Okay, after written the heading, you have to write that as a measure of intensity or degree of linear relationship between two variables, Karl Pearson, in this age, in between this age, a British biometrician developed a formula called as correlation coefficient. Okay, he taken large number of data, and he found one equation which will be give you degree of correlation between two random variables. So correlation coefficient between two random variables x and y, usually denoted by small r in bracket capital X capital Y. Pause the video, write down the note. Okay, or simply you can write small r subscript of capital X capital Y is a numerical measure of linear relationship between them, and it is defined as, this one: rxy equal to covariance of xy divided by standard deviation of x into standard deviation y. So if r will be positive, then we can say that both x and y are uh, so called positively correlated. That means one increases, other will be increases, and if negative, then we can say negatively correlated. Okay, here one thing I want to say to you, that whenever you have to draw this figure, don't forget to write this one: r greater than 0, r less than 0. Okay, perfectly clearly you have to write down. Now we know previously very well that covariance of xy is nothing but expectation of, I have to zoom somewhat. Okay, expectation of x minus expectation of x into y minus expectation of y, that we know. Or here we can write, see, expectation of this much. That means suppose we have n number of random variables, x is the x have the n number of values, and y random variable also n values. So expectation of this one will be 1 by n. So summation over this and this. You got my point? See, expectation of x is nothing but summation over xi by n. Okay, number of x points, number of x values divided by n. Okay, you see, suppose we have a random variable. Random variable x, and x values are 1, 2, 3, 4, like this. So expectation of x is that means expectation of x is nothing but addition of this one divided by 4. 1 plus 2 plus 3 plus 4 by 4, 4, 4, 3, 7 to 9, 10, 10 by 4. So this is nothing but the mean value will be give you how much. Here you can see that we can get the mean value is your 2.5. Okay, same thing, same concept here has been used, that summation over this one xi, all the values of x, minus this is expectation of x is nothing but x bar, we can write here yi minus y bar, a summation, so 1 by n. And variance, this is nothing but your variance. Okay, square of the standard deviation is nothing but variance, that we know. So sigma x square is equal to expectation of x minus expectation of x whole square, that we know very well. So this can be written as 1 by n summation over xi minus x bar whole square, and sigma y square will be nothing but expectation of y minus ey square equal to 1 by n summation over yi minus y bar square, no problem. So here summation extends from I from 1 to n. Okay, here I'm going to tell to you that clearly you have to write all the steps. Okay, put the heading that Karl Pearson's coefficient of correlation, and what I discussed, that these things you have to clearly write down in your note, and up to this much also. And again also covariance of xy, then what we are going to write, see here 1 by n, this into this. So this into this means you just multiply, we can get xi y bar minus x bar yi plus x bar y bar, right? So here you can see each term will be 1 by n xi yi minus x. See here y bar is nothing but mean, is a constant value taken outside 1 by n summation over xi. Here this one will be x bar 1 by n summation over yi plus x bar y bar, no problem. And we, as I discussed, that expectation of x is nothing but xi by n, or we can write x bar, no problem. For yi we can write, for this case instead of xi, if we are consider yi, it will be y bar. Okay, same thing here I am going to write that. Here you can see that 1 by n summation over xi is nothing but how much. Here this can be, this will be how much. Here you can write another step, 1 by n summation over xi yi minus y bar, this will be x bar, right? Likewise this is the x bar is already there, x bar, and this will be 1 by n y I, nothing but y bar, and then plus x bar y bar. So here x bar y bar got cancel, and we found that these two term remaining. So covariance of x equal to 1 by n xi yi minus these two are constant, so we can write instead of y bar x bar, we can write x bar y bar, right? So here covariance of xy can be written in this form. Okay, variance of x this one, variance of y this one, already we discussed here. Now after that you have to write the remarks. Whatever written in the remarks, clearly you have to write down in a note from following the figures, or you can write from the scatter diagram. Here from the scatter diagrams, here write that, because scatter diagram you have been written in your previous section, right? So from scatter diagram, and we discussed coefficient of correlation. So from the scatter diagram, here we have write remarks, you have to put the heading remarks, and you have to write from the scatter diagrams the standard data. See, I think this point already written at the bottom of this figure, so I think no need to write the first point. Don't write the first point, no problem, because already at the bottom of the figure already you written, so no need to write this first point. Second point, it may be noted that rxy provided a measure of linearship between x and y. You have to write down this one. For non-linear relationship, however, it is not very suitable. This is most important point. Whatever the relations we found by scattering data, that is only a linear relationship, not non-linear relationship. That means we can say, suppose this line is your y is equal to mx plus c, but this is your curve y is equal to x square. For this y is equal to x square is a non-linear graph. For non-linear graph it is not valid, only for the linear shift. Here we are searching the linear combination or linear coupling between the two random variables, right? Sometimes, now say this point, sometimes it may be convenient to write. Here you just write down covariance somewhere. You can see that in our next video or next section, whenever we are going to discuss or many places you can found, instead of covariance it has been written that sigma xy. Okay, Karl Pearson's correlation coefficient is also called as the product mean correlation coefficient. You have to just remember, because maybe in your exam it will ask that define this one instead of Karl Pearson coefficient. So you have to remember that Karl Pearson coefficient is nothing but product mean correlation coefficient, since this one equal to this one. Okay, So here we have to stop our discussion. In which way I have been told to you that you have to write down or maintain your note. You have to maintain and ready for the next class. In the next class, we are going to discuss that how this uh, co- correlation coefficient of correlation or correlation coefficient value is in between minus 1 to 1. See here, r value is in between minus 1 to plus 1 always. R value, okay, r value is always in between minus 1 to plus 1, but when r equal to 0, that means there is no linear relationship between x and y. So if negative, it is negatively correlated, positive, positively correlated, right? So thank you so much for watching this video. Thank you. Write down the note and ready for the next class.